Now this is an important question where we compare the strength of the acids. Now Ka is a dissociation constant for acid. For if the acid is strong, if the acid is strong, then Ka is larger values, which means that pKa has to be the smaller values. Now what's the idea behind? How do we compare the acidities of two or three acids? So always what you do, you find the conjugate base. How do I find the conjugate base? Now when we say, for example, if we have an acid of the form Ha, just remove H plus out of it. What remains is the conjugate base. Now if this conjugate base is stable, right? If it is stable, stable means the stability in organic chemistry is inversely proportional to charge concentration. So if you have, let's say, a resonance effect, or you have negative inductive effect which lessens this negative charge, then this negative field is less, and in presence of a lesser negative field, this H plus can go in the solution relatively very easily. Now the extent of stability in conjugate base is determined by the extent of the minus effects. It can be negative inductive effect or it can be negative resonance effect. So if you have the X molecule, which is sulfonic acid, now if you draw the structure of conjugate base, clearly this is the structure of conjugate base for this. For Y, this would be CH3CO O minus, and for Z, this will be CH3O minus. Clearly, here if you see, the delocalization is far better because it can delocalize. This is a part of a conjugate system, by the way. Double bond, single bond, lone pair, single bond, double bond. So if you draw the resonating structures, you will get more structures over here. How many structures you will get? You will get three. Negative charge appearing over here, then delocalize appearing over here, then appearing over here. And here again we have the resonance, but we have two structure. More is delocalization, better is the stability. And if the conjugate base is more stable, which means this reaction will go in the forward direction, which means it is going to generate more H plus. Here something very tragic happens. Why? Because it's a positive inductive effect. So if it's a positive inductive effect, the density of electron increases, and in view of the increased electron density, H plus cannot escape easily. Therefore, clearly, if this was the case of a acidic strength, I would say Z would be more acidic than, sorry, X would be more acidic than Y should be more than Z. This was the acidic comparison, acidic nature comparison. But when we say pKa comparison, it is just reverse, because what is pKa? pKa is nothing but minus log of Ka, which means it's a negative scale. So it is just the reverse of the observed trend over here. So it would be, for this case, the answer would be X should be less than Y should be less than Z, which means for this case option is B.